Troy Daniels here, head of technical training here at SimpliPhi Power. Thanks for joining. Today should be a pretty short presentation, actually. This is definitely one closer to the 30-minute mark with questions and everything. So we'll get started, but we should have plenty of time for Q&A at the end. If you have any questions during the presentation, go to the control bar. You'll see that Q&A tab. You can type out any questions throughout the presentation. And at the end, we will go through those questions. Perfect. Well, with that, let's go ahead and get started. So what are we talking about today? We're kind of talking about best practices, the do's and don'ts, as I call it, but more related to the don'ts, and the do's are just kind of what you do in place of the don'ts. So these are kind of some of the common mistakes we see in the field, and how it relates back to damage regarding the battery, and basically just how to avoid that, as well as kind of troubleshooting and understanding what certain symptoms might be related to. Just a little bit on company history to start, for those that are not aware. SimpliPhi Power, safe, proven, simple technology. Safe is this non-toxic, non-hazardous, cobalt-free lithium chemistry, which takes away the risk of thermal runaway with fire propagation. UL certified 1642 on a cell level, 1973 on a battery level, and 9540, that should say 9540, not 9540A. I apologize for the typo, on a system level, as well as 9540A testing. UN DOT certifications 3480, 38.3, and SCHIP approved for those in California. Proven technology, over a decade of experience and growth, deployed in over 40 countries, over 100 megawatt hours installed worldwide. Pretty small number at this point. That was written quite a while ago, so I haven't ran the numbers in a while. We've been tested and validated by the US Army and Marine Corps, special permission to fly the FAA, and manufactured in the US. Simple technologies, we look to always keep things as simple as possible, integrating and optimizing any generation source, grid, solar, wind, generator, whatever it may be, on and off the grid, and trying to utilize our batteries for the most simple but efficient methods of lowering cost of energy through things like time of use, peak load shaving, and demand charges. Our batteries are, again, lithium iron phosphate. This is our lithium chemistry we are using with a cylindrical form factor. This is kind of the basis of everything we do here at SimpliPhi Power, and gives our batteries really most of their characteristics. Okay, so jumping into the actual presentation, we're going to start just talking about some of the kind of common do's and don'ts. We'll start with over discharge, and I'm kind of put these in order that makes sense because it's what I see the most. So over discharge is by far the most common mistake in the field, and I would argue maybe the most damaging mistake in the field. So over discharge can be caused by several conditions, but all relate to exceeding either max continuous discharge and max discharge at 10 minutes. So those are specs found on the battery. So if you're looking at like our 3.8 kilowatt hour battery, you can assume 37.5 amps DC per battery is the max continuous discharge, and the max discharge at 10 minutes is 80 amps DC per battery. So regardless of how it happens, something has to happen here. So that'll kind of make sense when I talk about sizing of inverter. I harp on inverter sizing a lot when it comes to our standard Phi batteries. And a lot of people will say, well, I know the loads are so minimum, it won't matter. That's completely fine if that's the direction, but over discharge has to be caused by exceeding these limits. So if we see over discharge, even if you think your customer maybe didn't push the battery too hard, they have to have done something to cause this over discharge event. So if you're looking for that information on these specifications, really you can look at warranty spec sheet. Those are all going to be congruent with each other, meaning they're not going to have differences between what we call in the warranty for max discharge and what we call in the spec sheet itself. Integration and installation manuals are super helpful when it comes to over discharge. They have sizing guides directly on there related to the specific warranty. So if you see, we've got the Radian here, the 8000 model. This is too few batteries. We need literally too few batteries. So we need minimum of 4 batteries on this inverter. And really, actually, we can even claim 5, but we don't run 8,000 watts continuous out of this inverter. There's some efficiency loss, so 4 batteries is the minimum. So that can be found in their integration guides. If you look around in there, you'll find sizing, and you'll find sizing references specific to different products. So maybe it's a Schneider or an Outback or a Solarc. You'll find that different sizing. We have tools. We have the sizing tool. We have both the based on kilowatt hours. That's the more basic tool. But we have a system sizing tool that incorporates in the inverter you're using, the chargers you're using, and calculates out those minimum sizes. If you're looking for the specs on the battery themselves, right on the top of it, you will see these specs called out on max discharge. It is called out right on the battery, so you can't miss it when you're installing. It's right there in plain sight. The easiest way, and I'm just talking about the Phi battery here to start, the easiest way to avoid over discharge of the Phi battery is to properly size the battery bank to the inverter ratio. So 2-to-1 ratio, meaning if we have 8 kilowatts of inverter, we would require a minimum 16 kilowatt hours for the battery bank size. That means that if the inverter pushed out all of its 8 kilowatts, and not all inverters, definitely some are kind of coming around on this, but for the most part, most inverters without comms will not limit their discharge. It's not programmable. It's simply just how much it's going to discharge. And even if it was programmable, you're still relying on the programming of the inverter, which can fail sometimes or change depending on firmware updates. So it's important to kind of the ratio is the easiest way. You can't go wrong. If the inverter is sized correctly and the battery bank is sized correctly to that inverter, you will not have over discharge. It's the safest bet. We can use our SimpliPhi battery. So the SimpliPhi has closed loop communication, which actually allows for flexible sizing and automatic populated set points. So it basically can tell, it acts as the brain and can tell inverters that it communicates with not to over discharge. But if you're using the standard Phi battery, I always recommend sticking to this ratio. You won't have any issues there and you won't run up to over discharge. The battery sizing tool, again, easiest way to do it. If you have any concerns about sizing, just call us. Maybe you're just almost breaching the sizing requirements. Just give us a call. We can probably work through it, walk through it, talk about, why, maybe there's some inefficiencies that allow us to allow for less batteries than the ratio. So just call us. AC coupling, I leave that little mark there as it's always important to talk about. AC coupling, well, actually, we'll leave that out for charging, but I'll come back to it. But AC coupling does make things a little different. This ratio is really important when it comes to AC coupling on both the inverter side and the PV side, meaning the PV should be the 1 and the battery be the 2. So same kind of deal as the inverter. And I'll talk a little bit more about that later on. So SimpliPhi Power has numerous tools and support to help with system design. If you're having any issues or you're concerned about this kind of over discharge with sizing, we offer pre-sale support and system design confirmation. We have sales application engineers on the line ready to talk through sizing. So it's never a bad idea if you're just a little curious, maybe I am not 100% sure that my sizing was correct on a few of these systems. Maybe systems you already put in place, just give us a call. We can work through it and make sure we get everything correct before we see damage. The battery sizing tool is based on load. The battery sizing tool based on system design and sizing is the real one you want to use. There's the link for it. And you'll have that after this presentation goes out, but that's the real link you want to use for sizing based on system design to avoid over discharge. So I cannot preface this enough. Over discharge is not covered under the SimpliPhi warranty, meaning if the system design is incorrect and over discharge occurs, it will not be covered under warranty, because over discharge will not occur if system is sized properly per the warranty, per the spec sheet, per the integration guide, per the installation manual, per all of our literature. You will not have over discharge that will occur if everything is sized correctly. Some signs of over discharge include low cell voltage. So the battery might be showing low voltage. This is a kind of a tricky one. Let's say we have a 48 volt battery and it's showing, 45 volts. That's a different issue. If it's showing, let's say, 20 or 30 volts, or maybe even like 2 volts, that could be an indication of low cell voltage. Not always is an indication. It might be that the battery management system has gone into a protective state and caught the issue before it actually became a really big, significant problem. Sorry, just popping up, make sure questions are going. Okay. The battery management system might disconnect. That could be a sign of over discharge. That does not mean that breaker actually flips. That just means that the battery has gone into an open circuit internally. Typical signs of this will be extremely low voltage on the battery. Again, that could be a sign of protection, but it also could mean that the over discharge occurred already. Breaker flip on the battery bank. This is really common with over discharge. They are just physical breakers. And if the over discharge event is so significant that it exceeds those limits, the breakers might flip, even if the over discharge has already occurred. And the battery will not hold a charge when load is applied. That's a huge symptom of over discharge. Under severe circumstances, battery internal wiring and components can see excessive heat. So I've seen it before. If you put pulling way too much current out of these batteries, you might see some excessive heat, not on the cells most likely, but on the wiring and the components within the battery. So those can all be signs of over discharge, and that's something to watch out for. Moving on to the next kind of, I would say, second most common issue is low battery voltage. So SimpliPhi batteries are designed for 100% depth of discharge. Typically, this can be measured by voltage during discharge conditions. The SimpliPhi batteries are not designed to operate below 100% depth of discharge. And this can often cause damage if repeatedly dropped to a lower voltage. I will say one thing about low battery voltage. There's a little bit more give there where the BMS will most likely disconnect. And if you screw up once or twice, it's probably not the end of the world. The battery just probably needs a charge and a reset. This is something that will cause damage more likely if repeat offense. You just continue to over discharge the battery over and over and over again. That's when oftentimes this will become more of an issue than the other, like over discharge or overcharge. There's definitely a common misconception, definitely not amongst seasoned installers, but amongst maybe people that are just getting into the field, that 100% depth of discharge means the battery can be discharged to 0 volts. Can't tell how many times I get a call from somebody that's doing it themselves. They are putting the battery in, installing it on maybe their home or whatever it is, and they are so confused at why 0 volts does not correlate with 0% state of charge. And I always kind of try to bring them back to thinking about like a car battery. And sometimes that works, sometimes it doesn't. But typically the battery is at 0% state of charge, 100% depth of discharge at 48.0 volts, 24.0 volts for a 24 volt battery, 12.0 volts for a 12 volt. Super easy to remember since it actually just falls right into the name, the kind of commonplace nameplate. And while the battery management system does have internal disconnect, it is not designed to be used in place of proper programming, meaning low battery cutout. That's kind of the most important thing to keep an eye out. That LBCO is the most crucial way to avoid over discharging the battery as far as the voltage is concerned. Low battery cutout basically can be used to ensure battery voltage stays within the specified range. We'd rather that the system shuts down or goes into a standby mode, then the battery continues to discharge below its designated 0% state of charge. It also prevents manual reset on the batteries if it works correctly, meaning that the batteries can still charge and the system can still turn back on if the low battery cutout is programmed properly. It's programmable on most inverters, but it is always important to check inverter range. Some of the older inverters might not be able to hit the specified low battery cutout that we're talking about. So for instance, if we're looking at, let's say maybe a 48-volt battery that has 48.0 volts, like that's the maximum low battery cutout. I know it's kind of confusing to say maximum when I'm talking about the maximum low voltage, but this is kind of the best way to put it. Some of the older inverters might not be able to hit that. They might be set for lower. They're used to lead acid batteries. Lithium wasn't even around when they were created, so, or at least it wasn't being utilized. So that oftentimes you want to double check that with older equipment. The SimpliPhi battery, our newest, comms based battery, does auto populate SOC based disconnects, meaning it doesn't need low battery voltage. It automatically knows how to calculate its state of charge based on percentage and voltage internally. So it does all that kind of guess and check work for you. And it will always go into a low battery protection mode if needed. Low battery disconnects are sold as standalone products as well. So this, I've seen people use these. This is the Victron battery protect over here. These are super commonplace if you are using DC loads. So DC loads are kind of interesting in a way, as let's say you have an inverter that you're using AC loads with, and you have DC loads on a system. The inverter might go into low battery protection mode when the voltage hits, let's say 48 volts. And that'll stop the AC loads from pulling from the battery until the battery's at a better state of charge. But the DC loads are not going through that inverter, and they will continue to pull typically if they are left unmitigated and pull the battery down below that. So I can't tell you how many times I've seen that too. Definitely with do-it-yourself people, I see that a lot. They want DC loads on a system, maybe an off-grid system that has AC loads and DC loads. And the battery might go into low battery protection mode on the AC side of things through the inverter, but DC loads are still pulling from the battery, pulling it well below its 0% state of charge. Something like this will prevent that. Super important if you have DC loads, put some sort of external low battery cutout disconnect in. You'll save yourself a ton of issues. Damage caused by excessive low voltage discharge is not covered under warranty. Settings for low battery cutout and voltage ranges can be found throughout simplified documentation. If the battery hits internal BMS, battery management system cutoff, it is often can be recovered, as I mentioned earlier, but may require an external charger. So what I mean by that is if the battery is dropped so low that it's unable to basically support the capacitors of the maybe charging equipment, the inverter charger, the charge controllers, you might need to get a plug-in charger, something that can plug into an AC source and charge the batteries direct. Not always the case. Sometimes a simple BMS reset will work, but if you've dropped it well below its actual threshold, you might require that. And again, damage is a lot less likely when it comes to low battery voltage than it is to over discharge or overcharge, but it still can occur. In some cases, battery will exhibit extremely low voltage. It can no longer hold voltage. Circuit will not engage in these situations. You might have done some damage there. Maybe you hurt some internal wiring or just dropped those cells to the point where they don't want to hold the charge anymore. So again, it can happen, not as common, but it can happen. So it's something to watch out for. Okay, moving on, overcharge. So overcharge, super similar as far as the damage seen by over discharge, but let's just look through some of this here. Overcharge can cause battery damage, which is similar to the damage experienced by over discharge. Depending on the charging type and system design is super easy to avoid overcharge. I would say it's 1,000 times easier to avoid overcharge than it is to avoid over discharge, because the sizing does kind of mess people up sometimes if they're just thinking about customer needs and not the inverter to the battery size. The charging is really easy. DC coupled systems use charge controllers typically, or I would say almost, I can't think of a situation where they really wouldn't. Those can be easily programmed, even with an oversized PV, respective to the charge controller, they all have their limits, in order to limit the charge to the battery bank. So, you've got a 3 kilowatt PV array and your battery bank can only handle 1.9. Your charge controller can typically be that threshold point. Super easy to program. Say, I don't want it to ever charge more than this. And that'll work almost every time, as long as the programming doesn't get scrubbed for any reason, which is always good to check after a firmware update. AC coupled systems are a little bit different. They rely on frequency shifting typically to curtail PV. While this can limit the charging, we don't recommend you rely upon it. I've seen too many times in the field where the system does not curtail fast enough. And let's say you've got 10 kilowatts of PV and you're trying to curtail it down to 8 to charge the batteries. And it's just not quick enough, and it overcharges the batteries and it can hurt the batteries. It dumps that entire array into it. So we just recommend sticking with that 2-to-1 ratio. So your battery bank, if it's 16 kilowatt hours of battery bank, don't go higher than 8 kilowatts of PV. That way you never run the risk of overcharging when it comes to AC coupling. DC coupling, again, a little easier to kind of manipulate the settings, and it's kind of a little more tried and true. I know I'll probably get some comments as in, hey, well, it's come a long way and it does work really well. I would agree it has come a long way. I think we still kind of, based on our engineering input, we still want to stick with that ratio, but I do agree it's getting closer to being a little bit more efficient on that curtailment. Okay, so overcharge is not covered under warranty. It's important to note that some signs of that's a typo there, overcharge, and maybe it's a good typo because the signs are basically the same. So it's important to understand the signs of over discharge and overcharge can be very similar. They can include low cell voltage, as I mentioned earlier, battery management system disconnect. Again, that's not the breaker flipping, that's the internal circuit. The breaker flip on the battery bank, though, battery will not hold a charge when load is applied. And one that's a little different than discharge signs is the high cell voltage readings. So if I see these a lot with AC coupled systems. If it went into a state of overcharge, maybe it's sitting at like 64 volts on the battery, that's probably a sign you've overcharged your battery. Under severe circumstances, battery internal wiring components can see excessive heat. All right, let's talk a little bit about some other types of damage before we wrap up here and go into the Q&A. Some other, but I would definitely say less frequent causes of out of warranty damage include water environmental damage. Water and environmental damage is never fun. And I can't tell you how many excuses I get when I see this. We get a battery in and it's got water damage. It's really obvious if it's got water damage. It's actually really important too, and I think I go into this later, but it's important to keep in mind that if you are shipping a battery back for examination to us, let's make sure it's packaged right, because we don't want that battery to get water damage on the way, or else the root cause analysis is really hard to determine without looking at the water damage. Does happen though, just keep in mind water environmental damage can hurt the battery or at least cause some repairs that need to be done. Reverse polarity, I've seen a few of these, that's never fun. The battery will do its best, but if you keep pushing it, it's going to eventually not be able to protect itself from that. Improper wiring and imbalance, this one's pretty uncommon, but I've seen it. Maybe this has to do with torque specifications, or you're running everything to a small DC bus that can't handle. And low or high temperature charging. This one is really uncommon. While we have our thresholds for low and high temperatures, it's pretty rare that I think I can think of maybe one or two. I can think of one off the top of my head. I'm sure there's two situations where low temperature, it wasn't actually high, it was low in both those cases, caused the damage, and it really caused a degradation in the battery, not actual damage. These are less common than over discharge, overcharge, and low battery voltage, but they definitely can still be some causes. This actually on the right here is a example of a water damaged battery. So you can see kind of the very clear signs externally. It's not always that way. Sometimes you might not see the signs until you open the battery, and then there's internal water damage. The batteries are not NEMA 3R rated. The case that we offer NEMA 3R solutions to put the batteries in, but the batteries themselves are not NEMA 3R rated. So you got to keep them in an area that's dry. So talking about technical support and battery damage root cause analysis, technical support should always be contacted immediately if the battery experiences any of the mentioned signs of damage. So that could be, if the BMS opens or the circuit breaker goes off. Those are things, reach out to us right away, because oftentimes the battery may be able to recover if damaging circumstances does not continue unchanged. So basically, if we can fix the situation, I think that was kind of worded a little incorrectly, but if we could find the situation and fix it from the get-go, oftentimes it won't cause bigger damage down the road. So if you always tell your homeowners or whoever's watching over the system, if they see one of those signs, give you a call, get us on the phone right away. We'll troubleshoot to try to work through it. We can work through various system issues that may require system information in order to come up with next steps and conclusions. Basically, the tech support team is well-versed in different components, how they interact with each other. It's definitely good to talk that through with them. They can be a lot more helpful than you think when it comes to even system design issues that might have occurred that were kind of hard to catch. You can always reach us at our number there, option 1, or just email us at techsupport@simpliphipower.com. I mentioned this already. It is really important to ensure the battery conditions are the same from when they left to when they get to us. If you are shipping back to us for RCA, we don't always require this, but sometimes it is required. This includes proper packaging that can be provided by SimpliPhi Power Direct. You can also use the existing packaging. You want to avoid weather, such as water damage to the battery. I've definitely had batteries that were shipped back for analysis that had water damage on the way. We really have no way of determining if that water damage happened right at the time of shipping or if it happened a little bit before. Sometimes it might be obvious if it's wet when it comes to us, but again, that dries up pretty quick. Battery should be returned to SimpliPhi in the same condition it was operating in. RMAs, and actually this number is, I believe, even higher now or lower now than that. So made up less than 0.1% of all batteries sold in 2019. And of that, manufacturing defects made up only 0.1% of the above number. So meaning most of the RMAs that we ran through were issues with a system design issue. So it's important to kind of keep that in mind. We just want to avoid those. There's not a lot of RMAs in the field compared to batteries sold, but we just want to always keep that in mind. All right, a little plug for our installer qualification program. First and foremost, this program is designed to educate. So if it's a great way to basically ensure you never do any of these things, because we go through a lot of training to make sure that you don't. Basically, if you are already installing our batteries, join this program. You'll end up on our where to buy map as a little blip that shows you are somebody that's gone through this program. You can receive $25 cash back per battery just by becoming a member of the program. And you can also become part of the IQ photo contest, meaning you can submit photos and win $250 towards future SimpliPhi batteries. Rolling entries, you can keep basically submitting your photos until you win. And yeah, between that and the $25 rebate per battery, you can make some money back selling our batteries by joining the IQ program. So here's the link. If you need anything there, you can actually, we'll send out this presentation. You'll be able to click this link. It takes about 10 minutes to apply. So definitely, if you have time, jump right on it. It's super easy. All right. Thanks, everybody. I'm going to go ahead and pop the Q&A open. If you have any last minute questions, now's a good time to ask. I'm going to try to get through these as much as possible. The 2-to-1 ratio is stated as a minimum. Can the battery bank be more than twice the rating of the inverter? Absolutely. That's just the minimum. You can have, you could have 30 kilowatt hours on an 8 kilowatt inverter, not a big deal. So that's really just the minimum requirement. There's really no maximum requirement other than keep in mind your inverter can only do so much. What is a reset on the battery? How is it performed? When is it needed? Anytime the BMS opens circuits, you might need to reset the battery. It's oftentimes as simple as turning the breaker off, turning the breaker back on, maybe give it 15 minutes in between. This will power cycle the BMS, and as long as it likes what it sees, it will close that circuit. The hardest part may be sometimes if you need to, let's say you've gone into a low battery cutout situation where it's so low that you need to charge the battery. You might require a little charging before that reset occurs, or charging while you reset it to make sure the battery can supply enough power from the cells and wants to turn back on. If you are working with our utility so they can use your battery to peak shave, is that a problem because the utility pulls from the battery when the battery is not capable of supplying power? I think I'd have to see the specifics here, but really if you're peak shaving, and it should be related to the inverter, and as long as you size everything correctly to the inverter size, the battery should be able to handle any peak shaving if it's sized correctly. I'm looking at the cut sheet for the 5.3.8. If we set discharge voltage cutoff to 50 volts, we should stop discharge to 10% state of charge. Yeah. I mean, there's different, 50, you can go 48.0 to 50.2 is kind of my low battery cutout voltage range. And that's, 48 being 0% state of charge, 50.2 being 20% state of charge, or 80% depth of discharge. And last question, if you can share the link video. Yep, absolutely. It'll go out automatically from our marketing team. So just keep an eye on it in the next couple of days. You should see that pop up with the links and everything.